All right, we're going to talk about the addition and multiplication rule. Okay, so compound event. A compound event is the event combining two or more simple events. Okay, so the addition rule, notation for the additional. P, the probability of P or B is equal to the probability in a single trial event A occurs or event B occurs, or they both occur. Okay, so the intuitive addition rule, to find probability of A or B, add the number of ways event A can occur and the number of ways event B can occur, but add in such a way that every outcome is counted only once. Okay, probability of P of A is equal to that sum divided by the total number of outcomes in the sample space. Okay, so the formal rule, here's the formal rule, and this is probably what we're going to use a lot. Okay, probability of A or B equals the probability of A plus the probability of B minus the probability of A and B, where probability of A and B denotes the probability that A and B both occur at the same time as an outcome in a trial or procedure. Example 1, drug testing of job applicants. If one subject is randomly selected from the 555 subjects given a drug test, find the probability of selecting a subject who had a positive test result or uses drugs. So here's our information here, okay? So, solution, carefully count the number of subjects who tested positive, first column, okay? So here's our positive, okay? Or use drugs, the first row, but be careful to count subjects exactly once, not twice, okay? So we want to be here, we want to add these up and this one here, but we don't want to double up on our 45, okay? So 45 plus 25 plus 5 equals 75. So the probability of a positive test result or subjects uses drugs is 75 over 555 or 0.135. Disjoint events in the addition rule. If events A and B are disjoint or mutually exclusive, if they cannot occur at the same time, that is, disjoint events do not overlap. Okay, so these are disjoint events. Event A, randomly selecting someone for a clinical trial who is male, and event B is randomly selecting someone for a clinical trial who is female. Events that are not disjoint, randomly selecting someone taking a statistics course, and event B, randomly selecting someone who is female. They have overlap. Okay, summary of the key points of the addition rule. Find the probability of P or B, first associate the word or with addition. To find the value of probability of A or B, add the number of ways A can occur and the number of ways B can occur, but be careful to add without doubling counting. Rule of complementary events. So probability of A plus the probability of complement A equals 1. The probability of complement of A is equal to 1 minus the probability of A, and the probability of A is equal to 1 minus the complement of A. Example 3, sleepwalking. Based on a journal article, the probability of randomly selecting someone who has sleepwalked is 0.292. So the probability of sleepwalking is 0.292 based on the data from prevalence and the comorbidity of nocturnal wandering in the U.S. general population by Ohana, Neurology, Volume 78, number 20. If a person is randomly selected, find the probability of getting someone who is not sleepwalked. Using the rule of complementary events, we get the probability of not sleepwalking is equal to 1 minus the probability of sleepwalking, or 1 minus 0.292 for 0.708. Multiplication rule. Probability of A and B. The probability event A occurs in a first trial and event B occurs in a second trial. So the probability of B given A represents the probability of event B occurring after it is assumed that event A has already occurred. Interpret B given A as event B occurs after event A has already occurred. The intuitive formal multiplication. So intuitive multiplication rule. To find the probability that event A occurs in one trial and event B occurs in another trial, multiply the probability of event A by the probability of event B. But be sure that the probability of event B is found by assuming that event A has already occurred. The formal rule, the probability of A and B equals the probability of A times the probability of B. Okay, independence and the multiplication rule. Two events A and B are independent if the occurrence of one does not affect the probability of the occurrence of the other. Several events are independent if the occurrence of any does not affect the probabilities of the occurrence of others. If A and B are not independent, they are said to be dependent, right? So if I flip a coin and roll a die, the probability of getting a heads does not affect the probability of rolling a 2, right? But the probability of, if I draw a card out and keep it out, that probability, my first card is if I'm getting a specific card, might be 1 in 52. The next one probability might be 1 in 51, okay? The example 4, drug screening and the basic multiplication rule. Let's use only the 50 test results from the subjects who use drugs. Okay, this is from example 1. If two of these 50 subjects who use drugs are randomly selected with replacement, so we're going to pick a name out of a hat, we're going to look at that name, write it down, put the name back into the hat, shuffle them up again, do it. Okay, so that's what it means by replacement. Find the probability that the first selected person had a positive test result and the second selected person had a negative test result. Okay. So the first selection with 45 positive results among 50 positive. So that gives us a positive test result of 45 over 50. The second selection with 5 negative test results among the same 50 results, and the probability of negative test results is 5 to 50. So the probability of first selection is a positive and the second selection is negative is equal to 45 over 50 times 5 over 50, or 0.09. Sampling. Sampling with replacement. Selections are independent events. Sampling without replacement. Selections are dependent events. Okay. Treating dependent events as independent. The 5% guideline for cumbersome calculations. When sampling without replacement and the sample size is no more than 5% of the size of population, treat the selections as being independent, even though they are actually dependent. Okay, so we're going to do the drug sampling. Assume that 3 adults are randomly selected without replacement from the 247,436,830 adults in the United States. Also assume that 10% of adults in the United States use drugs. Find the probability that the 3 selected adults all use drugs. Okay? Because the 3 adults are randomly selected without replacement, the 3 events are dependent. But here we can treat them as being independent by applying the 5% guideline for cumbersome calculations. The sample size of 3 is clearly no more than 5% of the population of the 247 million people. So we get the probability of the first is what we're going to do is the probability of the first uses drugs and the second uses drugs and the third uses drugs is 0.1 times 0.1 times 0.1, or 0.001. So we get to use this probability as an independent event. Birthdays. When two different people are randomly selected from those in your class, find the indicated probability by assuming that birthdays occur on the days of the week with equal frequency. A, find the probability that the 2 people are born on the same day of the week, and B, find the probability that 2 people are born on a Monday. Okay. A, because no particular day of the week is specified, the first person can be born on any of the 7 days. The probability that the second person is born on the same day as the first person is 1/7. The probability that 2 people are born on the same day of the week is therefore 1/7. B, the probability that the first person is born on a Monday is 1/7, and the probability that the second person is born on a Monday is also 1/7. Because the 2 events are independent, the probability that both people are born on Monday is 1/7 times 1/7, or 1/49. Okay. Example 7, the Airbus 310, redundancy for better safety. Okay. Modern aircraft are now highly reliable, and one design feature contributing to that reliability is the use of redundancy, whereby critical components are duplicated so that if one fails, the other will work. For example, the Airbus 310 twin-engine airliner has 3 independent hydraulic systems, so that if one system fails, full flight control is maintained with the other functioning system. For this example, we will assume that for a typical flight, the probability of a hydraulic system failure is 0.002. A, what is the probability that the flight control will work with one hydraulic system goes out? Well, the probability of one hydraulic system does not fail is equal to 1 minus 0.002, or 0.998. What is the probability that on a typical flight, control can be maintained with a working hydraulic system? Okay, the probability it does not happen that all 3 probabilities of systems failure is equal to 1 minus 0.02 times 0.02 times 0.02, or 1 minus, 8 zeros and an 8, which equals 0.9999. There's going to be 8 9s and a 2 there. So this is the probability that all 3 are not going to fail. Okay? All right. So that's working on the addition and the multiplication rule.